Hello, BESS and BFS tutors. You're welcome to another unit or topic, and that is the chi-square statistic. Now, a chi-square statistic, we've been looking at testing a hypothesis. We have been using the mean, but then sometimes we might be faced by qualitative variables, and the normal distribution it may not be of help, maybe because of the small size of the samples, or because the quantities cannot be measured in exact terms. So the chi-square test basically looks at qualitative variables such as marital status, stem color, sex, and so on. So it looks at the qualitative variables. So those are both ordinal and it basically looks at categorical events, and qualitative distribution is extensively used when testing for independency of any two distributions. So we always compare the observed proportions of frequencies to the mean or to the expected, and therefore we make use of this formula to get a chi-square statistic or test. So where O means the observed frequency, then E is the expected frequency, K is a constant, and C is the number of individual operations or observations of a paired group. So a chi-square distribution values, if the values differ little from the expected values, then the chi-square value is also little. But then if the differences are large, then the chi-square will also be large. So this is an outline on how to conduct a chi-square test. So we start still by stating the null and alternative hypothesis. Then we get the chi-square tabulated. Still, chi-squares use degrees of freedom. So we use degrees of freedom and then the alpha level or confidence level to get a chi-square tabulated. We use the chi-square table, which looks like this. So for example, at alpha equals 0.05, or this is at 95% alpha, confidence level. If we are interested in a chi-square, if a sample is maybe of 10, the degrees of freedom will be 9. So the chi-square value is that value that corresponds to 0.05 alpha and then to 9 degrees of freedom. So after we use the formula to get the chi-square calculated, and we always compare the chi-square calculated to the chi-square tabulated, or the one we get from the table. So if the chi-square calculated is greater than the chi-square tabulated, then we reject the null hypothesis. So this is now the level of decision making. When what you get from the calculated or from the formula is greater than from what you get from the table, then you reject the null hypothesis, and vice versa. Or if it is less than the chi-square tabulated, then we do not reject the null hypothesis. So we have an example that in a trial production run, 5 machines produced the following quantities of defective items, and we are interested in finding out whether these machines are equally efficient. Remember, chi-square tests for independency. So are they equally efficient, or one of them or more than one of them is not as efficient as the others? So we have this observed number of defectives, and then what will be the expected number of defectives? We have a total of 120. So to get the expected still means the mean. So to get the expected number of defective items, we shall get our total and then divide by the number of items. So to get our E, we shall have 120, or the total of all this, and divide it by 1, 2, 3, 4, 5. There are 5 machines. So we can use that to get our chi-square calculated. So the solution, the first step is to always state the hypothesis. And remember, the researcher is interested in finding out whether machines are equally efficient. So meaning the researcher's claim is that machines are not equally efficient, and therefore the alternative will be that machines are equally efficient. So our expected value E, like I said, it will be the total of number of defectives divided by the number of machines, which will be, so under normal circumstances we would expect, since we are looking at a situation where machines are equally efficient, we are expecting each of them to have the same number of defective items. So which will be this, divided, and we divide it by the number of machines giving us 24. So therefore we are going to subtract each observed value, and we are going to subtract the mean or the expected value from each observed value, because we are interested in the difference. So therefore for machine A, the difference between the observed and the expected will be 25 minus 24. Machine B, 24 minus 24, 20 minus 24, 28 minus 24, that 23 minus 24. So this is our difference, but remember our formula has a square, so we square the differences. So meaning chi-square values can't be negative because we square. When you square negative, you get a positive as well. So that is it. Then we come and substitute in our formula. So we shall have the summation of O minus E will be 1 plus 0 plus 16, which is 17, plus 16, which is 33, plus 1, which is 34. And we are dividing it by the expected value, which is 24. Therefore, our chi calculated will be 1.42. So to get, remember, you're supposed to compare the chi calculated with the chi tabulated, or the chi value we get from the chi-square table. So to get chi tabulated, we use degrees of freedom, and since we have 5 classes, which will represent our n, the degrees of freedom will be 4, so which is n minus 1. And since the level of significance is 0.05, so we can get chi tabulated. So we are looking at 4 degrees of freedom and 0.0. So this is our 0.05 and 4 degrees of freedom. So 0.05 and 4 degrees of freedom, which is 9.488. So coming back to our example, so the chi tabulated is 9.488, or rounded off to 9.4. So we are supposed to compare chi tabulated and chi calculated. So the tabulated one is 9.49, and then the calculated is 1.42. And remember we said that when chi calculated is less than chi tabulated, we do not reject the null hypothesis, but when chi calculated is greater than chi tabulated, we reject the null hypothesis. So for this case, our chi calculated is less than chi tabulated, so we do not reject the null hypothesis, and therefore there is enough evidence that these machines are equally efficient. So then the differences in the number of observations were maybe by chance, but then in terms of effectiveness, the machines are equal. So that is it with the chi-square statistic. You can read more. Yeah, thank you so much, and stay safe.